In this one, we are building neural network with one hidden layer to classify planar data, non-linearly separable data, and we are using Python, TensorFlow, Keras, and Matplotlib to generate and visualize planar data, build, train, and evaluate neural network, and visualize decision boundary, and save the neural trained model for future use. So this tutorial is perfect for beginners who want to understand the basic of neural network and how to implement them using Python. So firstly, we're importing all the necessary libraries. All these libraries, NumPy we use for numerical computation and handling arrays. Matplotlib we use for data visualization, plotting dataset, and decision boundary. TensorFlow Keras for building and training neural network. Make moons, that's a function from sklearn to generate 2D dataset that looks like two interleaving half circles, like planar data. And the train test split is a split, the thing to split dataset into training and testing sets. So after that, we're going to generate planar data. So that's what this is. The make moon function is a thing where we generate 2D datasets with no classes. The noise parameter adds randomness to the data, making it more challenging to classify. So visualization is where we scatter plot to visualize the dataset. The cmap plot.cm.spectral argument colors the point based on their class labels y. Then we're going to split the data into training and testing sets. And training split is 80% where we use to train the model, and testing set is the 20% thing. So that's how we normally split the data. That's testing set is used to evaluate the model's performance on the unseen data. And random state is that's for ensuring reproducibility by fixing the random seed. Now we are building and defining the model now. So as you guys can see here, sequential model, a linear stack of layers. That's what it is. Then dense layer is a fully connected layer. So we have 4 neurons with the ReLU activation. Rectified linear image is popular activation function for hidden layers. Then output layer is our sigmoid, where one neuron with sigmoid activation is used as a binary classification as it outputs a probability between 0 and 1. Now we're using compiling the model. So the optimizer is adaptive moment estimation. That's the popular optimizer for training neural networks. And loss function is binary cross entropy, which is used for binary classification problems. And metrics accuracy is used for evaluation of the model's performance. And model summary, that's what we print the summary of model's architecture here. So that's how all things are. And then we train the model. So fit function trains the model on the training data. Epochs are a number of times the model sees enter dataset. Batch size is the number of samples received before updating the model's weight. Validation split is a split that splits the training data into training and validation sets. 20% for validation. Then verbose, that controls the amount for logging during the tagging, 1 for progress bars. Then after that, as you guys can see, it took a while to train the model. We ran 100 epochs, and after that we evaluate the model. So the function evaluate is for testing the model on unseen test data. Then test accuracy is the thing where we measure the percentage of a correctly classified sample. scatter is a plot where it plots the actual data points. So that's all it is. So with running all these things, you guys can see this pretty looking image where we made the decision boundary. Then we're going to plot training history. So training history is the track of the loss and accuracy during training. A loss plot is something that shows how the training and validation loss decreases or evokes. And accuracy plot is something that shows the training and validation accuracy to improve or evokes. Then that's the output of everything which I said right now. So after that, we're going to save the entire module with module.save. And normally modules are saved in the edge file thing. And we're going to export this module. As you guys can see, this is our exported module, and we got accuracy of 86%. That's something. Then basically we generated and visualized planar data with the neural network with one hidden layer. We trained and evaluated the model, visualized the decision boundary and training history. We saved the model for future use. Now, there might be some concepts like decision boundary, then verbose, then split, then epochs, then binary cross entropy, then atom, then dense network. All these things might not make sense right now, but we are going to learn all those things in the upcoming videos. And yeah, until then, keep tuned, stay tuned, and keep learning.